Hi everyone. My name is Disha Ray from Decision Lab, and I'm very pleased to be here. Today, I'm here to present our strategic simulation platform, which we co created with AstraZeneca, and it focuses on engineering the anti fragile supply chain. A little bit of introduction on me. I am a consultant at Decision Lab, and I specialize in software engineering. And co-presenting with me would be Gareth Alford. He is the new Technology Innovation Director at AstraZeneca. Unfortunately, Gareth couldn't make it today, but he has sent us a recording and he would be introducing the challenge to you in the next slide. So this is Gareth, and I'll play the video where he describes the challenge.
Hi, my name is Gareth Alford, and I'm a new Technology Introduction Director, part of the Manufacturing Technology and Strategy team here in AstraZeneca. My world revolves around a simple yet incredibly complex goal: working with our talented scientists, turning science into medicine at a global scale. A critical part of this is planning for the future, deciding where and when to invest millions of pounds in new manufacturing capacity to meet the needs of patients for the next decade. For years, like much of the industry, our long-range planning was anchored in a familiar process, a complex web of disconnected spreadsheets and manual data consolidation. The honest truth is, this process was painfully slow and inherently fragile. What that meant in practice was that our view of the future was based on a single deterministic forecast. We were planning for a perfect, straight line in a world that was anything but. This wasn't just an operational headache, it was a strategic vulnerability when looking at aligning new technology investments to business needs. When you face pipeline uncertainty, shifting global demand, and supply chain disruptions, making £1 million decisions based on a single, fragile view of the future introduces a significant risk when it comes to new technology investment. We realized that simply reacting to the short-term portfolio needs was placing our new technology platforms on the critical path for product launch. This is an unacceptable position, and we needed to be able to look at the long-term impacts of the technologies to support strategic business investment decisions. We needed to fundamentally change our approach. We needed to build a system that could thrive on uncertainty, not just withstand it. And that set us on this path to this collaboration and anti-fragility.
Thank you, Gareth. I'm going to pick up from where Gareth left and describe the concept of anti-fragility. So over the last few years, we proved we can survive disruption, but surviving isn't just the goal. Our goal is to turn volatility into an advantage. So on the left here, you can see 3 different outcomes, and I'll explain each of them with examples from the 2020-2022 semiconductor shortage in the auto industry. So fragile systems, they broke. Companies like Ford, GM, and Volkswagen relied on just-in-time supply chains, and when the chips ran out, production stopped, costing the industry over $200 billion. On the other hand, resilient systems survived. Toyota, having learned from the 2011 Fukushima disaster, required suppliers to hold months of inventory. And when the shortage hit, Toyota kept factories running while competitors stalled. On the contrary, anti-fragile systems go further. Tesla treated the shortage as an opportunity. Instead of waiting, they rewrote software to use alternative chips and deepened control over the supply chain. Every disruption made them more adaptable and competitive. So that's the shift we made. Resilience alone is defensive. It keeps you from losing, but it rarely helps you win. So we built a system that learns from noise and stress, so every cycle makes us fitter, just like training your muscles in the gym. So this required a fundamental change in our philosophy, from reactive plans to proactive ones. The intent isn't just to endure volatility, it's to thrive on it and create a competitive advantage over it. In the next slide, I'll introduce our platform. So we designed the strategic platform to operationalize anti-fragility so that the system doesn't just withstand shocks, it improves because of them. The platform replaces traditional Excel-based workflows and unifies 3 different simulation models linked end-to-end. Under the hood, simulations run on AnyLogic Cloud, React provides the web UI, and a Node.js backend acts as the server. We use WebSockets between AnyLogic and our API so that the app can stream status and results in real time. On this slide, you can see 4 different screenshots from the platform. The first screenshot on the left shows a branching tree where each node represents a scenario for one of the models. You can create multiple branches, pass outputs from one scenario to another, and resume from any checkpoint. The next screenshot displays an AnyLogic animation run of one of the models. You can see assets progressing from one phase to the next. This lets users visualize flow, spot any bottlenecks, and validate assumptions, so the results are easier to understand and trust. The third picture shows a graph of multiple runs. It helps us understand the stochasticity in the model and how results vary from run to run. It helps us spot patterns, quantify any uncertainty, and choose effective strategies. The final screenshot is the scenario comparison view, which lines up scenarios side by side, so you can immediately see how they differ based on key KPIs. This helps users pick the scenario that best fits the goal under uncertainty. So a natural question, especially for this audience, might come up is why AnyLogic for a challenge of this scale? For us, it came down to 2 capabilities that were essential to meeting AstraZeneca's anti-fragility goals. The first is range-based planning. We can't bet on a single forecast. We need to see how a plan holds up across many plausible futures. AnyLogic lets us run Monte Carlo experiments, thousands of trials with varied inputs, so we see the full spread of the outcome. It makes it practical to choose strategies that work across the range and not just one fragile point. The second is modularity. We didn't build on one model, we built 3 different models. One is the portfolio, demand, and the capacity model. These need to evolve independently. So with AnyLogic Cloud, each model runs its own service and it is called on demand through the API. We can update or scale one without touching the others, isolate issues quickly, and still deliver a single seamless experience to users. Thus put together, they provide the anti-fragile foundation we need. So as I mentioned earlier, the platform connects 3 different models: portfolio, demand, and capacity. So I'll explain briefly what each one does. The first is the portfolio model. It stimulates potential future assets and how they move through the lifecycle stages in the R&D pipeline. Next is the demand model. It takes the portfolio outputs and converts them into quarterly forecasts for the next several years. Finally, the capacity model. It takes the outputs from the demand model and evaluates different manufacturing scenarios and investment strategies to make sure those forecasted demands can be met under a range of conditions. As you can see in the diagram, we can selectively pass the tables we need from one model to the next, so only the relevant data flows forward. Each model is independent, and the platform stitches them together so data moves cleanly, runs are repeatable, and we can pick up from any checkpoint. So that's how we turn 3 specialist models into one streamlined decision workflow. On this slide, we're showing how the platform shifts us from single point forecasting to range-based planning. It also acts as an educational tool, making anti-fragility tangible and helping drive a culture shift so that everyone in the business understands and uses the concept. This is the multi-run view of the portfolio model. Instead of asking what's the forecast, we ask what's the range of plausible futures. We run the model many times using Monte Carlo, adding realistic randomness and then plotting the outcomes together. The heat map on the right shows the number of assets launched per year. And on the left, you can see the runs with the run IDs. In the heat map, the runs with the darker cells indicate outcomes that occur more often in the Monte Carlo, thus visually conveying the uncertainty and where the distribution clusters. As you can see from the graph, in 2026, the most common outcome is 26 launches with a probability of 40%. And most runs are falling between 23 and 26. So that range matters. Planning for 23 assets versus 29 assets leads to different resource, budget, and capacity choices. So we plan to a range and not just a single point. On the left, we can filter which runs to carry forward as inputs to the next model in the chain. This lets us test decisions against different futures, not just one run. So in summary, by simulating thousands of scenarios and working with the full range, we choose plans that hold up under variability rather than ones finely tuned to a single fragile point. In this slide, you'll get to see the more exciting part of the app running in real time. So I'll play the video and I'll explain what's going on. So this is the home page of the app. And initially we have to import the data, which exists in the folder structure of the stakeholder running the app. And we navigate to this graph view. This graph view basically helps us visualize and understand the passing of outputs from one scenario to another, and it depicts which scenarios are related, thus making it easy to compare the results and also to understand the analysis. So when we click on this node, we can start by creating a portfolio scenario from the beginning. So we are entering a scenario name here. We are entering some tags to describe the scenario so that it's easy to understand and find the scenario later on in this page. And we click on continue, and this takes us to the inputs page of the scenario with some default inputs filled out. So the ones you can see on the UI are the basic inputs, and the non-technical users can interact with those. But if you're a more technical user, you can go into the more detailed inputs, which can be accessed by downloading the Excel sheet, changing it, and re-uploading it. And once we're happy with the inputs, we click on run, and this takes us to the run page, where if we can see this, and if we click on the run button, this starts running the embedded AnyLogic animation. As the portfolio animation runs over here, you'll see that assets advance phase by phase from the candidate selection phase to phase 3. So this is a model of AstraZeneca's research and development activities that determine which assets will be commercialized. You can see in the timelines that some assets make it all the way to phase 3, but many are terminated before reaching the phase. You can analyze and visualize that the candidate selection phase and phase 1 are more densely populated, and finally, only a couple of the assets make it to phase 3. So once the animation finishes, you can go to the outputs page, which shows the results graphically as well as in a tabular format. It highlights all the key KPIs. It would help you analyze the results. And another feature here is you can add more scenarios and compare their KPIs as well. And as you can see here, we're adding 3 different scenarios, and we're comparing the KPIs in the graph as well as in the tabular format. So now previously we showed you the single run. Now we'll show you the portfolio scenario running in the Monte Carlo run. So in this page, we enter the number of runs we want in the Monte Carlo run. There's no animation, but the platform sends a call to AnyLogic. AnyLogic runs the model with the inputs, and then once the model finishes running, AnyLogic reverts back to the platform via API calls. And once the platform receives the output, you'll be able to see that a message flashes up, and you should be able to go to the outputs page. And if we click on the outputs page, we can see here that the graphs are a little different from the graphs you saw for the single run. So the graphs here, they bring the full range of uncertainty, and each run reflects a possible future. You can see how the manufacturing estimates shift as the portfolio changes. You can filter the runs, and you can also visualize how each of the graphs change, and you can get your analysis from there. And from this output page, you could also create a demand scenario, which is the next consecutive scenario. You give it a name, you give some tags to describe the scenario, and you can also filter which of the runs you want to pass as inputs to the next model. And if you click on continue, it takes you to the input page of the demand scenario. And the look and feel is quite similar. The only thing that differs is the tables that's present here, which is different to the portfolio scenario tables. And if you click on run, it looks quite similar, and this will run the demand animation. If we click on the run button, the AnyLogic embedded animation shows up, and there are controls. You can play, pause, fast forward. And over here, I've fast forwarded it so you can see it. You can see the animation running quite quickly. So once the animation finishes running, you will receive the outputs from AnyLogic. And if you click on the outputs button in the bottom right corner, it will take you to a similar page that you saw for the portfolio scenario with all the graphs. So the look and feel is quite similar, but the inputs and outputs, the KPIs vary. So yeah, that concludes the demo. In the next slide, I will talk about the impact that the platform made to AstraZeneca. So the impact, it shows up in 3 different ways. The first is automated workflow. We replaced slow manual Excel-based data handling, which led to copy-paste errors, fragile links, and weak versioning with an end-to-end pipeline. This frees the AZ experts from spreadsheet work so they can focus on high-value strategic analysis. The next is a shared language. The UI is quite explainable, it's visual, and it's educational. It helps different teams highlight pain points, align on targets, and get the same message across, thus reducing friction and speeding up decision making. We can also say that it gives technical teams and leaders a single trusted view of all the models. The final is data-driven confidence. Range-based results are transparent and user-validated, and by modeling at a higher level of detail, by breaking modules into sub-modules, we are striving for higher accuracy. So this lets leadership de-risk high-stakes investment and network decisions with robust evidence. So to put it simply, it provides greater agility to AstraZeneca. In the final slide, we'll talk about the future of this platform. We're now pleased to announce that we're moving into the next phase of the development, which is focused on scale and day-to-day usability. Building on the success of phase one, and with the customer very happy with the outcomes, we are working with AstraZeneca to deliver phase two. And some of the features to be included are model versioning across all the models. So we'll introduce version control for portfolio, demand, and capacity. That means different versions of each model, side-by-side comparisons, and rollback whenever needed. So changes are traceable and teams always know which versions they're running. The next is multiple capacity models for each asset type. We'll add different capacity models rather than just one single capacity model, and each model will be tuned to different asset types. They'll plug into the same platform, so we can select the right capacity model for the problem while keeping a consistent workflow. The third is richer UI. We aim to incorporate enhanced visualization features and add interactivity to animations to improve user engagement and clarity of simulation results. So that marks the conclusion of our roadmap, and that also marks the end of the presentation. Thank you for listening. Hope you enjoyed it, and we'll be happy to answer any questions. And if you do want to take this further, please do get in touch with us. We'll be happy to get in conversation on the topic, and we've also added the contact details, so please feel free to reach out. I'll go into the questions. What makes this a digital twin as opposed to a simulation tool? And also, how often do you import real data? So this is a digital twin. It's similar to a digital twin because it replicates what happens in real life. The simulation replicates the modeling that we do is replicated as to the processes that occur in real life, which is why it's a digital twin as compared to a simulation tool. And we import the real data whenever we want to run any model. We start the app, and all of the data right now in the demo that we showed, some of the data might be historical, but we always, the platform is enabled to use real data. Is custom UI scenario manager is based on AnyLogic Cloud API, or is it a fully custom solution? It is a fully custom solution. We created the solution using React and Node.js. So it's bespoke and it's catered to linking all the models together. I want to use this right now. Thank you. Please do reach out to us. How did you test all the different features of the system to ensure user needs are being met? So we did some rigorous testing. We conducted two kinds of testing with users. One of the methods was user acceptance testing, which involved writing out various sets of detailed steps and validating that the users were happy with the outcomes. We also used the system usability scale so that we could get feedback on the usability of the system and benchmark it against what the software development industry considers to be a good score. How is the real data imported into AnyLogic as Excel files? So the real data consists of JSON and Excel files. So the whole structure is stored in a JSON file. And when you import the JSON file, and when you're running the model, it individually imports all the Excel files that's required. Is the Monte Carlo run using a built-in AnyLogic function, or it's a custom developed functionality? So my colleagues, Jacob and Peter, who have worked on the modeling side of things, would be um, more best fit to answer this question. So they'll be there in the chat to answer this question for you. And I'll pass it over to them. Did you adjust for demand uncertainty from competition or other uncertainties? Again, this is Jacob and Peter are more well-versed on the modeling side of things, and they are also present, and they would be happy to answer it in the chat for you. Your presentation highlights a modular architecture with 3 different models. Could you elaborate on the technical challenges of integrating this model? So in terms of technical challenges, we had to go through a lot of API calls. We had to ensure which API calls to AnyLogic work. We had to also ensure that they're not time complex enough, and they're quick enough. So those were the most significant challenges we faced while integrating the 3 different models together, I think. API calls and also considering the time complexity involved. Could you please explain the difference between digital twin and simulation tool? So yes, a digital twin uses real live stream data, whereas a simulation tool might not use a real live stream data, but it is quite similar to a digital twin in the sense that it replicates the processes that are used in real life, but it does not really use the real live stream data, but rather works with current data, which might not be live streamed. How do you define the levels of the relationship between the models, like how much each model impacts each other? Again, I think this is something Jacob and Peter, who've worked on the modeling side of things, would be best to answer. So they will revert back to you in the chat. Looking at your future roadmap, how do you plan to balance the development of new technical features like richer UI and new model versions with evolving strategic questions from the business? So that's a good question. We are taking both into account. We have to be led by AstraZeneca's priorities. At the moment, they have new strategic questions about capacity, which we are looking to support by building new simulations to integrate with the platform. But we also have to balance that alongside improvements to the user experience. So they are both important strands, which we are looking to progress in parallel. All right. Yeah, I guess that's all the questions. Are there any other questions? How did you build trust with senior leadership to secure the investment, and how did you ensure ongoing engagement and adoption of this data-driven approach among strategic planners who might be used to more traditional methods? That's a good question. Uh, so to answer that, we built trust by showing value fast with a clear, explainable UI, no black boxes. Leaders could see trade-offs and outcomes side by side. Splitting the system into 3 models let the stakeholders see everything in the bigger picture, thus creating like a common language for decisions. And to drive adoption, we used education by design, interactive visuals, scenario comparisons, and short planning sessions. So the tool teaches as you use it and becomes part of everyday planning. You mentioned live stream data. How did you ingest the live stream? And sorry, I was mentioning it just to give a comparison of digital twin and simulation data, but the platform currently does not use live stream data, but it just uses current data. If you have current data stored in the form of Excel sheets, you can upload it to the platform and work with it. Did you adjust for demand uncertainty from competition or other uncertainties? My colleague Peter, he has answered this question. So regarding demand uncertainty, we take stochastic demand profiles from historic data to randomly generate the demand. This creates a spread of possible futures. This historic data will account for things like external competition. I just read out what he mentioned.